At the beginning of this session, Klaus highlighted the importance of digital skills and digitalization of manufacturing. Key issue is how to develop training content and particularly tools that will help to this in terms of those training skills. So what we've done within the Perform project is to develop a training device. And this device consists of a number of areas. One is additive manufacturing. Secondly, the use of IoT, the use of Internet of Things. Thirdly, the use of augmented reality. And finally, that of digital twin. Now, how to combine these all in the same device? So what we've done is we've fabricated a turbine system, and this turbine system has to be printed. Now, we can print it either in metal or in polymer. And then the next step is to actually test it and obtain information from it. So we developed an apparatus which we can work in real time and remotely. So we can work in terms of it on tablet devices. So in other words, as the turbine rotates and we know the level of air being blown, so the turbine rotates, we obtain real-time information in terms of the performance of the turbine device. So you can actually see it on the screen here now. So these are the small turbines that we've printed in metal. As I said, we can print it in polymer. We've already worked in terms of using this as a training exercise. So you see some undergraduate students here working on it. So we've already trained 100 students. And so you can see the turbine rotating inside in a small little holder here. That's a flywheel. And as the flywheel moves around, you obtain data in real time on the tablet. And that information you can control the speed of the turbine. Each of the students can also see it on their own mobile phones, for example. And in addition to the speed of the turbine, we can also measure acoustic information, temperature, and humidity. So these are the IoT elements. In addition, we have augmented reality. So what's shown here is an example of IoT and how to extract, or augmented reality and how to extract, for example, the turbine from the device. So the AR information is overlaid on top of the operation of the turbine itself. The piece I haven't shown you here is the digital twin. And what we do is we have a series of operations where we have training data, and then where we have anomaly data within that data. And we can show how the digital twin can be used as a predictor of where a problem is arising during the use of the turbine. So in summary, therefore, this Perform turbine device consists of IoT, augmented reality, digital twin, and of premier importance in this is additive manufacturing and the formation of the device. And that combination together can really be something that both industry and undergraduates can use. Thanks very much for your attention.